Hello everyone, I'm Snehal Purani. So with this lecture we are again moving forward in our journey of solar energy with Sunny. So today's video is all about on information on solar energy estimation tools that we have discussed earlier, that the basic information regarding this energy estimation tools will be given step by step. So in this video, I have included these tools: PVsyst, SketchUp, Helioscope, Autocad, PlantPredict, System Advisor Model, PVWatts calculator, and RETScreen. So the basic information regarding these tools I have discussed in this video. So beginning with the PVsyst, this is the team core committee or core member team of PVsyst team. He is the developer of the main idea of PVsyst software development goes to this man. Name is Andre, and the technical supporter who had wide experience of practical field in the solar energy systems. This man is Michael. These both the key members of this core team, and now all the team working for the better functioning of this PVsyst tool. So Andre has doctorate degree in particle physics and has carried out in-depth studies of energy systems like solar energy, thermal building, photovoltaic systems within the framework of the University of Geneva. He had developed this tool only for the study and simulation purpose of the photovoltaic system, and he is now heads the company PVsyst SA, who promotes and markets the solar software applications. He is the initiator or founder member of the PVsyst software. Michael Willows, he is the photovoltaic engineer, and he has been working as a project engineer and trainer in the solar world since 1980. So he has wide experience in this solar photovoltaic system, and he is advising and teaching the optimization of grid connected PV systems and the calculation of autonomous photovoltaic systems, means hybrid system as well as on grid system or off grid system, the requirement of storage system, the pumping application, everything can be simulated in the tool, and he is the advising member or the teaching member in this committee. So PVsyst was founded in 1992. It was started to develop the PVsyst software for the study and simulation of photovoltaic system. Then later on, they have developed the 3D shading construction, the simulation of standalone PV system and pumping PV applications, including some research about modeling of the batteries and storage system and pumps. So with this tool, you can directly design or construct the solar photovoltaic plant as per your requirement, as per your need at your location. He also conducted research for a specific model of PV modules on any available technologies in the market. So PVsyst is one of the most well-known solar design software, and it is the oldest one and most widely used and accepted solar simulation platform. There are many other simulation tools available which we are going to discuss in this video itself, but PVsyst is accepted globally, and all the other tools which they are utilizing for the estimation, they have the basic knowledge of PVsyst as well. PVsyst is quite comprehensive and provides us a great result for large utility scale projects. Means with the help of this, you can design the ultra modern solar power plants, the capacity which is in terms of gigawatt or in terms of huge amount of megawatts. Some basic features of PVsyst are as follows. You can utilize this software tool for system designing, its sizing. We can create a shading scene to realize the exact situation of the generation at the location. You can simulate and result, and the results can be printed, and it is available in PDF format as well. You can model storage system as well for the off-grid system or hybrid system. Some additional features include importing the meteo data or the component data, the weather information from other sources or other simulation tool. It is possible with the incorporation of such information from the other sources than this tool itself. You can simulate the aging effect of solar modules and find out the degradation of the generation capacity of the power plant after certain amount of years of operation. With this, solar designer are utilizing this tool, and the major function or the most important factor while the calculating the operational efficiency of solar PV power plant is the effect of shadow on our module. That how much amount of shadow, at what time the shadow is falling on the power plant or some amount of panels, that is to be taken care of while we are designing a solar PV power plant for a specific location for the consumer at our place. So with the help of this PVsyst, we can create this 3D simulation and to reflect the actual scenario and check the shadows of various objects on our solar power plant and its effect on the generation. For the analysis purpose, we can compare the reports of various scene and layouts for the study purpose and analysis purpose. This simulation reports generated by the PVsyst give us an overview of how much energy our system can generate and what kind of losses are occurring during this period, and after this generation and these losses, how much amount of energy is being injected into the grid can be estimated using this tool itself. The advanced feature of this PVsyst is it includes the simulation of storage system, where we require the off-grid system, where we can design the system for the householder with the help of this islanded solar PV power plant. So for this, we require the consumption limit of that consumer, as well as how much amount of storage capacity we require at this place, considering the amount of days of autonomy, the power failure, etc. So this dynamic design we can incorporate, or we can easily carry it out with the help of this PVsyst tool. So with this tool, we can design on-grid system, off-grid system, and hybrid system. We also can design the special application like pumping with the help of this tool. The main feature of this PVsyst tool is the meteo data. The meteo data is required to find out the exact amount of generation, as the solar power plant is site dependent and mainly dependent on the irradiation at that location, the temperature of that location, the amount of wind flow, the wind flow direction, the wind speed, then the other parameters are important in this. So these weather dependent parameters can be incorporated in this tool. Solar projects are dynamic in nature and are different, and the generation which we are getting at particular location is always different than the other location, because it is territory or geographical location based operation or performance can be realized with this tool. For the example, if a plant designed for India, the same plant in America will not functioning altogether similarly. This PVsyst provides us a feature wherein we can import the weather data right from Meteonom, NASA. There are other agencies which can provide us the weather data for our application at that location. So this can be easily incorporated in this PVsyst tool. But generally we all are preferring this Meteonom data for the calculation purpose. This Meteonom is a third-party software. It has a wide range of database for the weather at different locations available across the globe. So whatever the location that you choose, you can easily find the Meteonom data for that location with the help of this Meteonom data tool. So we need to incorporate this Meteo data for the exact amount of generation to find out the simulation to be more realized. Suppose that this PVsyst has many features wherein we can add or import the latest solar PV modules, latest inverters in it. Suppose if you find out any module which is not listed in this PVsyst software, you can incorporate the .pen file of that module and similarly .ond file for that inverter, and with this you can run check the compatibility for this module or that inverter for your purpose of generation, for application purpose, for the system performance evaluation, for the comparison purpose, for the analysis purpose. So this is the best feature that PVsyst is offering. Also gives the features of aging, with the help of which we can find out the amount of degradation of a solar PV module after some amount of time. So if suppose you want to find out the degradation of your installed solar power plant after 5 years, so with the amount of percentage degradation you can enter it in this, and after 5 years you can find out the amount of degradation of generation at that and if you want to find out the degradation throughout the lifetime, so you can find out for 25 years the degradation in generation with this tool. So more realized generation of your power plant can be realized using PVsyst tool. Also with the help of this PVsyst, you can have the other features like simulation of bifacial modules. You can create patch solutions and other features as optimization tools for this. So this is the information or basic idea of PVsyst tool, with which you can design your solar PV power plant as per your need, as per your requirement, at your convenient location, as per your time. This is the best software I have came across till date. And this PVsyst software is readily available for the users for 30 days trial version, and in this 30 days trial version all the features of the main software is readily available for the users to check out. So now moving up for the next tool, that is SketchUp. SketchUp, this information is readily available on the Wikipedia. You can go through it. The scripting language for the SketchUp is Ruby, and using this Ruby script you can add new functionality to your program. This SketchUp was first released in year 2000 and initially published by Last Software, but afterward in 2006 it was bought by Google for the convenient purpose, and in 2012 Google had sold it out and to the California-based company Trimble Incorporation. SketchUp is the program which is used for a wide range of 3D modeling projects for architectural, interior design, landscape architecture, and video game design for the earlier purposes. This program includes drawing, layout, functionality, surface rendering, and supports third-party plugins from the extension warehouse. SketchUp is the initiative of 3D modeling application that lets you create and edit 2D and 3D models with a patented push and pull method. With this push and pull method, if you want to add any object into your design, you can simply push it, and if you want to change the layout of that or hide dimensional changes, you can easily push or pull that as per your requirement in the design itself. SketchUp has found the success with the people who want to create, share, or download 3D models for use with 3D printers. SketchUp was created in 1999 by the last software. In 2006, Google acquired SketchUp, and in 2012, uh, it was bought by Trimble Navigation. Now it is Trimble Incorporation, as Google had found out the most powerful tool, that is Google Earth. Uh, it makes drawing your design easy because the software is built to function like your hand. SketchUp Pro is the powerful 3D modeling software with which you draw the lifelike portraits or drawings quickly and easily, with a wide selection of architectural styles that fits your design well and thus impress your client. SketchUp Pro supports these third-party extensions, and there's an option for you to place your model within Google Earth. So, in a way, you can easily place or switch your design to the modern or highly rated by the Google platform, that is Google Earth. Now SketchUp became obsolete for Google as Google had found out Google Earth. So they have developed a technology that can create 3D models almost automatically. But the drawbacks of using manually created models have been eliminated thus far. But this image data that previously used for the SketchUp is consistent. With the help of these pixel colors, you can find out or analyze the photos of an area and selecting the average color for that pixel location. This looks the entire map as coloring. From that coloring, you can find out the amount of irradiation level or amount of depth or anything that you can analyze properly with the help of this color coding. The quality is amazing, that is no doubt about it. The result is a lifelike view of that means the vision is so powerful that you are visualizing from the window of an airplane by your bare side. With the help of stereo photogrammetry, potentially all buildings and landmarks can be modeled in Google Earth. The placement of each object is highly accurate when compared to the manual placement of the models from SketchUp. Currently, the new 3D models in Google Earth are only available on the mobile platform. It is available in limited cities, but Google had given you a chance that if you want to place your model into Google Earth, you can easily incorporate your location and your model into this Google Earth platform. In a way, Google Earth is spreading its fame and enhance the operational capability of this Google Earth tool. The next tool is Helioscope. The ancient meaning of Helioscope is it is an instrument. It is used in observing the sun and sunspots. The Helioscope was first used by Benedetto Caselli and refined by Galileo afterwards. The method involves projecting an image of sun onto a white sheet of paper suspended in a darkened room with the use of telescope. It is a web-based sales and design tool for solar professionals. It features a 3D design engine and energy yield simulation, a detailed financial calculator, and drag and drop proposal editor. Folsom Lab is the developer of this solar PV design tool, Helioscope. This tool aims to simplify the process of designing and engineering of solar PV systems. So basic idea of this Helioscope is that it is a web-based sales and design tool for solar professionals with the power to completely reshape your proposal generation process. With this tool, you can design your solar PV power plant 5 to 10 times faster, and this tool is helpful for the designers as they have to carry out this design process as faster as possible to attract their clients and to serve their client better. Helioscope provides a web-based user interface with solar layout tools and energy simulations. Other features of Helioscopes are we can find out the solar panel layouts, shading analysis, single line diagram export, 45,000 component library, quick design revision, Google Map integration, .pen file support, unlimited design and 3D design. And the most feature is API, application programming interface, with which we can simply communicate with the other tool as well. It is supporting computer-aided drawing tools, solar energy production estimation and system loss chart is available. You can find out the voltage drop calculation and wiring selection for your purpose or for your application. One-click sharing is available. SketchUp shading integration is there. National Renewable Energy Limited (NREL) meteor data integration is there. Up to 5 megawatt system can be designed with this Helioscope drawing. Helioscope offers an API for our users so that you can automatically pull your project, design and simulation data from Helioscope directly into other software. The next tool is Autocad. This Autocad was derived from a program that began in 1977 and released in 1979 called InteractCAD, which is afterwards was written prior to Autodesk then, and it is known as MicroCAD. Then the extent of localization varies from full translation of the product to the documentation only. The Autocad command set is localized as a part of the software localization. The first version by Autodesk was demonstrated at the 1982 Comdex and released in the month of December this same year. Autocad supported CPM-80 computers. Autocad had become the most ubiquitous CAD program worldwide by March 1986. This is the basic Autocad information available on Wikipedia, the release date, the operating system supported, the languages available in. The basic information of Autocad is limited not only to this, but if you find out or if you want to know more about it, you can directly click to this Google, this Autodesk link, so which will be redirected to the product overview. This Autocad is created to enhance the creativity with automation, collaboration and machine learning features of the architects, engineers and constructional professionals. With this tool, you can design and annotate 2D geometry and 3D models with solids, surface and mesh objects. The automated tasks such as comparing drawings, counting number of objects, adding blocks, creating schedules and more can be easily done with this tool. You can customize your workspace and maximize your productivity with APIs available in this tool. ESRI Map 10 permits export as AutoCAD drawings files. Similarly, other extensions are available for the countrywide, and the conversion of .pdf file is possible with this tool. But the result is unpredictable and distorted. Sometimes the jagged edges may appear. Several vendors provide you online converters for free, such as Comet Docs. The nomenclatures which are utilized by several professionals as per their application need or area of functioning means if aerospace engineers, they call their final design as an assembly. Automotive calls their final design as a part design. Electrical and electronics engineers call their final design as blueprint and circuit design. Rail and marine professionals call their final design as layout or blueprint. Structural and civil design engineers call their final design as layout. Architectural drawing of all kinds is available. Interior design and facility planning also available, and they also call their final design as layout or plan view. Workflow charts and organizational diagrams, proposal and presentation can be prepared. Graphs of all kinds available with this AutoCAD application. With the AutoCAD, you can draw for electronic, chemical, civil, mechanical, automotive and aerospace engineering applications. Animation and application is very much utilized nowadays of this AutoCAD device in entertainment creation for the high quality entertainment content using 3D animation software. To enhance the productivity and tight deadlines, the professionals are utilizing this tool for the visual effect creation. Modelers are used and animators are utilizing this tool to enhance their creativity. The other tool available is PlantPredict. One of the major information regarding this AutoCAD is you can simply draw and design your system in it. You cannot analyze the same with this tool. So for the designing and creation purposes, you can utilize this tool. This tool is not at all utilized for the analysis purpose. The most powerful tool available also in the market is PlantPredict. This PlantPredict is a highly powerful tool to find out the amount of electricity produced by the help of photovoltaic power plant, and the document can be find out as a report if you find out for a particular location of power plant for your design, for your required amount of structure at your location. The formal software architecture, graphical user interface, and implementation details are not contained right now, because as and when we are going for the hands-on practice with this PlantPredict tool, we are sharing with you the same. The input to PlantPredict consists of a time series of environmental inputs such as irradiation, the amount of radiation from the sun, temperature at that location, the requirement of the static power plant. It is the nested hierarchy of sub-assemblies to create the actual power plant at your location. A representation of a photovoltaic power plant is a set of model choices, simulation settings, controls. This will allow the user to combine the weather data, power plant model to execute the prediction to more realized design for your power plant, for your requirement. The output of the tool can be compared to the monitoring points in the actual power plant, such as irradiance, area current and voltage, power, maximum power produced by the array, the series diode connection to benchmark the tool performance against the actual generation. It is a cloud-based web application that allows user to develop solar energy estimates for utility-scale PV applications. It is specially tailored to provide monitoring points that align with utility-scale power plant standards. The distinguished feature of this PlantPredict is that the weather input is not limited to hourly data. Sub-hourly data, weather measurement from on-site meteorological stations can also be used for energy predictions, with which you can predict the amount of energy being generated and energy being injected into the grid more precisely or in real time. The power plant builder is a nested hierarchy of sub-assemblies allow for nearly identical replication of the as-built site. This PlantPredict tool is superior to conventional modeling tools in large part because it's cloud-based architecture, giving it more flexibility and security than typical desktop software applications. User can share their data securely within their company's PlantPredict community while maintaining peace of mind that the data is not spread across several desktop computers. Additionally, the cloud environment makes PlantPredict's API-based architecture possible. With these APIs, you can transfer your design in other tools. You can communicate with the other simulation tools for the comparison purpose or ease of operation of increase the user friendliness of the creator. From an operation and maintenance perspective, this offers a unique opportunity to automate the reporting of actual daily energy generation compared with the contractual models. One key differentiator of PlantPredict is the comprehensive validation testing against both actual plant data and comparisons against other industry applications. Primarily, the benchmarking of 1 gigawatt DC spread across 1 gigawatt DC capacity over 20 sites PV systems confirmed the PlantPredict under predicted energy by 0.41% plus or minus 2.01%. That is the highest amount of accuracy that you are getting it. While a validation exercise against a PV system using 51 equivalent simulations showed a mean energy yield difference of 0.13% plus or minus 0.52%, which is highly accurate. This validation exercise demonstrates that the PlantPredict is not only highly accurate but able to reproduce results from predictions previously run using other commercially available software. The full algorithm suite is available in the PlantPredict resource centers to eliminate any black box concern around how the algorithms are implemented. This is the overview of PlantPredict, in which this is the solar PV plant producing the DC power, and it is given as an input to this inverter. This inverter inverts this DC power into AC available power or utilizable form. This AC inverter power is directly given to the grid with the help of this transformer. Similarly, the second system is functioning like the same amount of systems, number of systems are functioning all together and directly connected to the grid. So the amount of generation is being fed to the grid. You can design for on-grid as well as off-grid system as per your requirement. The amount of parameters which are governing this generation are irradiance, spectrum, temperature, wind, soiling or snow, etc. can be easily programmed or easily can be changed by the user itself for the realization of the near about the actual situation or scenario at that location. Some parameters which we are utilizing for the creation of the system, and with this algorithm available in the tool itself, you can realize the more about the real-time situation of the power plant functioning. The next tool available with this is System Advisor Model, SAM. This tool is developed by National Renewable Energy Limited (NREL) with the funds of the US Department of Energy. SAM development team collaborates with industry partners, NREL staff and interns, and other research organizations to develop and enhance the model. The original solar models were developed in the collaboration with the Sandia National Laboratories and the University of Wisconsin's Solar Energy Laboratory. The System Advisor Model, SAM, is a free techno-economic software model that facilitates decision-making for people in the renewable energy industry, project managers and engineers, policy analysts, technological developers, and researchers. The hydrothermal resources where the underground heat reservoirs is sufficiently permeable and contains sufficient groundwater to make the resource useful without any enhancement. Enhanced geothermal systems that pump water or steam underground to collect the heat stored in rock. This system involves drilling or fracturing the rock to improve heat transfer process. Over the time, as heat is collected from the rock, its temperature decreases and more drilling is required. SAM's recapitalization cost amount accounts for the cost of these improvements to reach new resources. Both flash and binary conversion plants is available. So actually in this video we have not demonstrated the basic functionality of system advisory model for the utilization or for the application of solar PV modules, but we have discussed the other renewable energy resource like tidal energy or the hydrothermal resource available. As and when we are going with the simulation with this SAM tool, we are giving you the more insight about this tool in the upcoming videos. The next tool available is PVWatts calculator. It is also a web-based application for estimating the energy for the grid-connected PV system. The design is very simple and understand of non-expert and more advanced users alike. PVWatts hides much of the complexity of accurately modeling PV systems from the users by making several hidden assumptions about the type, configuration, and operation of the system. The result should be interpreted as being a representative estimate for a similar actual system operating in a year with typical weather. PVWatts has been online since 1999, and the original algorithms in version 1 were largely based on the approach of the Sandia PV form tool developed in 1980s. Several versions of PVWatts have been made available, though the system performance calculations have remained largely the same as in all the versions. In 2013, NREL began the process of revamping the PVWatts online web application to update the visual appeal and functionality, consolidate versions to reduce the ongoing maintenance burden, and update the energy predictions algorithms to be in line with the actual performance of the modern PV systems. This NREL stands for National Renewable Energy Laboratory, which is operated by the Alliance of Sustainable Energy with the funding available from the US Department of Defense. And this estimates the energy production and cost of energy of grid-connected PV energy systems throughout the world. And the small building owners, installers, and manufacturers to easily develop estimate the performance of the potential PV installations can be done utilizing this PVWatts calculator. The errors may be as high as plus or minus 10% for annual energy totals and plus or minus 30% for monthly totals for weather data representing long-term historical typical conditions. As the weather data is changing as per the current modernization or revolution in industry, the amount of generation being estimated utilizing this tool may vary in a huge amount or in high percentage. This is a useful map-based free online software for US and international PV sites analysis. It could give the global annual energy output of PV systems connected to the grid in USA or in many parts of the world. PVWatts also provide international solar maps. This powerful and easy to use tool is developed by the NREL. It works only for the crystalline solar panels. PVWatts calculator calculates the energy production and cost saving of connected PV systems throughout the world. It is totally free. It allows anybody to easily estimate the performance of the worldwide PV projects. PVWatts calculator provides also estimated monthly and annual irradiance and energy production in kilowatts and energy value. The users can select a localization and choose to use default values or their own system parameters for size, cost, array type, tilt angle, azimuth angle, etc. for the design purpose. The tool can provide hourly performance data for the selected location. With this PVWatts parameters, you can utilize DC rating, DC to AC, D rate factor, type of PV array tilt angle, azimuth angle, electric loss, cost, or estimation of the amount of losses, etc. can be done utilizing this. Some default parameters available in the PVWatts calculator is installed nominal operating cell temperature is 45 degrees centigrade, degradation due to temperature is 0.5%, angle of incidence, losses for a glass PV module cover, PV cell technology, crystalline silicon, mon or polycrystalline can be utilized. The last tool in this list is RETScreen. This RETScreen was developed by Government of Canada and it is released on 1998. RETScreen is available in recent version is 8.1 and only available on the Windows software. It is available in 37 different languages. For more information, you can directly go to this link for RETScreen. It is the first version of RETScreen which was released on April 30, 1998. The 4 versions were launched after till December 11, 2007 at Bali, Indonesia by Canada's Minister of the Environment. RETScreen Plus was released in 2011. This RETScreen suite was released in 2012. The RETScreen Expert was released to the public on September 19, 2016 with the more amount of functions and enhance the operational feasibility of the persons or designers. This RETScreen Clean Energy Management Software is a software package developed by the Government of Canada. It is highlighted at the 2016 Clean Energy Ministerial held in San Francisco. It is currently under development by the Government of Canada's Department of Natural Resources Canada in collaboration with the key international and national organizations, including the United States National Aeronautics and Space Administration (NASA). This advanced new version of the software will accelerate access to clean energy and allow a broad range of clean energy stakeholders to quickly identify, assess, optimize and track the performance of the clean energy investments over the entire project life cycle. It is the next generation tool is expected to be launched across North America and around the globe in fall 2016. Gregory J. Lang, creator of RETScreen Clean Energy Management Software, was a finalist for the Leadership Award at the Euromoney and ERMST and Young Global Renewable Energy Awards. He is the director of RETScreen International at Natural Resources Canada's Canmet Energy Center in Venice, Quebec. RETScreen empowers professionals and decision makers to rapidly identify, assess, and optimize the technical and financial viability of potential clean energy projects. This decision intelligence software platform allows managers to easily measure and verify the actual performance of their facilities and helps find additional energy savings or production opportunities. It is an advanced premium version of the software and available in viewer mode only. These are some references which I have utilized for these presentations. For better understanding, you can refer to it. With the great thought of Albert Einstein, I would like to conclude this lecture or video. The true sign of intelligence is not knowledge but imagination. Thank you. Thank you for the listening.